Hello, everyone. This presentation will share our work, Noisy Correspondence Learning with Meta-Similarity Correction, from Zhejiang University. Our work focuses on the noisy correspondence problem, which refers to the irrelevant multimodal pairs, but wrongly treated as matched ones. Noisy correspondence is inherent and pervasive in real-world multimedia data. For example, conceptual captions is a large-scale image-text dataset collected from the Internet, which contains about 3% to 20% noisy samples. Here we show some irrelevant image-text pairs from conceptual captions. Training with noisy correspondence data can remarkably harm the performance of cross-modal retrieval methods because the standard triplet loss will wrongly enforce the mismatched data to be similar in the common space. To tackle this problem, we propose a meta-learning-based similarity correction network termed MSCN, which aims to provide reliable similarity scores. To this end, we use a small amount of clean metadata to guide the training. Specifically, we view a binary classification task as the meta-process. Given an image-text pair, the MSCN is learned to determine whether the modalities correspond to each other or not. As indicated in the figure, the positive metapairs are taken from the original metadata, which contain corresponding image and text, while negative metapairs are extracted from different samples in the training set to construct mismatched pairs. The binary labels are produced from the data itself and can be regarded as the ideal similarity score to guide the training of MSCN. The output of MSCN measures the probability of a pair being clean, which can be naturally equivalent to the similarity score. Our proposed metaprocess enforces the MSCN to learn discrimination from positive and negative metadata and output reliable similarity scores. Next, I'll introduce the details of our proposed method. For the noisy training pairs, the mainnet learns noise-tolerant features guided by the reliable similarity scores produced from the metanet, while the MSCN predicts the reliable similarity score based on features from the mainnet. This interdependency enables the mainnet and metanet to reinforce each other against noise. Formally, the optimal parameter of the mainnet is calculated by minimizing the triplet ranking loss over training data. To achieve robust cross-modal retrieval, we design a self-adaptive margin to enable the triplet loss put more attention on the clean samples. For the metanet, the optimal parameter can be learned by minimizing the cross-entropy loss on the constructed metadata. Although our MSCN can provide reliable similarity scores, it remains to produce positive loss for the noisy pairs due to the property of triplet loss. Thus, we further propose a meta-knowledge-guided data purification strategy to remove samples with potentially mismatched data. Motivated by recent studies of meta-learning, we use a bi-level optimization strategy to guarantee the efficiency for updating our mainnet and metanet. As indicated in the figure, it is practically solved by two nested loops of optimization. We first update the mainnet parameters by taking a gradient descent step toward the direction of triplet loss. Then we update the parameters of MSCN with the mainnet parameters fixed. Finally, we update the parameters of the mainnet while fixing the MSCN parameters. Next, we will introduce the experiments of our method. This table shows the retrieval performance on MS-CoCo and Flickr under different synthetic noise rates. We can observe that our MSCN surpasses the baselines by a clear margin. The results at a noise rate of 70% show strong robustness of our method against the noisy correspondence with high noise rates. We also conduct experiments on the real-world noisy correspondence dataset. On the conceptual captions dataset, our MSCN achieves state-of-the-art performance in terms of all metrics. Here we also show some noisy samples detected by our MSCN. In the last pair, the picture shows a man covering his ears, but wrongly captioned as using a mobile phone. Although this picture is misleading, our method successfully detects this subtle difference. To evaluate the performance of the proposed components, we conduct the ablation study on the Flickr with 20% noisy correspondence. We can see that all components are important to achieve advantageous results. The visualization on the similarity score distribution predicted by MSCN shows that our method can successfully provide corrected similarity scores. The progressive comparison compared with another strong baseline shows that our MSCN achieves a more stable performance in the overall training process. To summarize, we tackle the noisy correspondence in cross-modal retrieval from a meta-learning perspective. And the main contributions of our work are summarized as follows. Thanks for your attention.